Okay, example D. Factor the quadratic equation by grouping. Then find the roots or x-intercepts or solutions. These are all kind of synonyms of each other. Now, guys, for today's notes, we're going to first start by finding the discriminant. Because if we do this first, we can identify if we can even factor at all. And then as we move forward, once we find the discriminant, this will be a key component of something we're going to do later using the quadratic formula. So it has value for us either way. So for this example here, let's start by finding the discriminant first. Remember that this is going to be b squared minus 4ac. That's our discriminant formula. If we use kind of a skeleton for that, it's b squared minus 4ac. You'll get very fast at this once you get used to it. In this case, our a value is 1, b is 13, and c is 40. So b squared would be b is 13, so 13 squared, minus 4a, a here is 1, so I put a 1 in here. And then c here is 40, so I'll put a 40 in that parenthesis. And again, with the calculator, this is not that difficult. 13 squared is 169. And then here, negative 4 times 1 is negative 4. And then negative 4 times 40 is negative 160. And if I subtract these two, I get 9. So when the discriminant is a positive number, I know I'm going to have two solutions. And in this case, 9 is a perfect square, so I now know that I can move forward with factoring. It's going to work because I found my discriminant first. Good, so with that, let's go ahead and factor. Guys, I'll go a little faster here. X factor, I get 40. Oops, sorry, I need actual ink. 40 and 13. And then 40 is 8 times 5. So that works out. I can write my original question as x squared plus 13x plus 40. And guys, again, notice how when we do this x factor, these side numbers are interchangeable. You can write them however you want. It'll always come out the same at the end. So write the 8 first or the 5 first. It does not affect the process. So I can now separate this bx term as plus 8x plus 5x. And then I can go ahead and group. So here I'm going to group the first two terms and the second two terms. GCF of x. And again, once we do this, we can write the second parentheses the same. Then in the second group of 5x and 40, they share a GCF of 5. So I can divide by 5 here. And I get x plus 8, and then x plus 5. So I've now factored my original quadratic. Again, I found the discriminant first because it was a 9, and it's a perfect square. I knew for a fact that I could then factor this quadratic. Now, once I have the factors to find the roots, take each factor and set it equal to 0, you can find your roots. So I can say x plus 8 equals 0, or x plus 5 equals 0, and I can solve. So here I find x equals negative 8, or x equals negative 5. Again, these are called roots, but they'll also be called x-intercepts or solutions, or in fact even zeros. So guys, get more comfortable as we move along, that as you guys solve quadratics by factoring or other techniques, you can be asked to find the roots, the x-intercepts, the solutions, or the zeros, and that all means the same thing.